All right. So this is the fundamentals of Bancor V3 simulations, and at a high level, this is really a series that we're trying to communicate how simulations can be done by the community, and so trying to provide as much information as we can for people who may be so inclined as to get into the weeds a bit and start playing around with this in a more low level way. And so we came out previously with this building Bancor simulations in Python, a step-by-step explainer, which is on Medium blog, and it's quite long. So I think 16-minute read. Of course, you could listen if you wanted to, but what we're proposing now is to kind of dig a couple layers deeper and kind of go through the background of everything that you would need in order to kind of replicate, doing that whole process yourself. And so, with kind of infinite ability to modify it as you please. So today we're covering state machines, state variables, containers, and interface concepts, and we'll briefly get into the code as well, and how to navigate around the simulator GitHub repo. And so with that, I thought it'd be good just to kind of kick it off with a little visual, which is super simplified, obviously, but maybe it'll help just kind of get the concept of what the state class in the simulator is doing behind the scenes. And so it's essentially a storage component. And with that, we were able to store all the state variables and process actions through something that looks like what we're looking at here. So Mark, any point in time, I'm just going to kind of keep going through here, but I'm sure you probably have some things to add, or if I miss anything, feel free to interrupt me here.
We'll start.
Cool. So the main concepts that we're talking about are state machines. And so a state machine is something which, what was that? No. State machine is something that just takes a set of inputs, right? And doesn't store anything internally. So the state transition function is just, it's going to perform some computation on the inputs and provide an output, but it doesn't actually store anything itself in this middle component here, which is a state transition function. The state machine itself, if you want to think about it, is like a set of variables, so to speak. We've got our inputs, our state transition function, outputs, and then kind of if it's finite state machine, then we've got like a finite set of all possible states. And so here, this is really simple representation of what we're doing with the simulator, but more specifically to the simulator is this, and I'm not sure, maybe I can make this a little bigger, where with the simulator, what we have is, an action, right? And this is like a user agent over on the left side. What we're calling the Bancor protocol kind of represented in the middle here. And then the processing that happens to change the state. So if a user performs an action, right, that's kind of this line that we're drawing across here. And so it could be a trade, a withdrawal, a deposit. And so the user provides some sort of input, right? If we go back to the previous diagram, the input is going to be what sort of action it is, how much the amount is for, so on and so forth. And that information is going to be um, you know passed through a series of functions that will that create an output, and then we'll update the current state. So if you think about this center column as how many what balances are in the vault or the staking ledger, um, all of these, by the way, are concepts that are in the BIP15 original document that we're looking at here. So really, the whole simulator, if you want to get to like the very core of it, is based around this specification. So if we refer to this the spec or the specification, we're referring to this document, which is linked on Bancor governance, right? BIP15 proposing Bancor 3. You can kind of scroll down and find these links. If you click the final version of the BIP15 document, you end up here. And so what we're saying is that the all of the ledgers that are associated with the V3 design, the staking ledger, and so on and so forth, are part of the state of the system. And so when a user performs an action, we have the current state and we process it through some functions, and then we update the state. And then the user, in turn, observes the state, so the newly updated state, and maybe they see, okay, well, the price has changed. Now I'm going to perform some other action, right? And it's just kind of a clockwise motion around this visual here is what we're really doing in the code. So I always find it helpful to kind of visualize things, and you can basically just go around in those simple types of actions that update the state, and then somebody reads the state, observes it, and performs another action. This is of course, what the Ethereum blockchain does. So if you look at the Ethereum docs, you'll see from ledger to state machine, and in the associated concepts that are involved with the Ethereum state machine. Likewise, just to kind of like emphasize that this is not uncommon. If you look at the Beacon Runner repo from Ethereum and you dig into it a bit, you'll eventually come down to something called state.py, which really, if you scroll through here, has not totally dissimilar types of concepts involved with it, where there's eventually a class which is called Beacon State, and then you've got associated parameters or attributes of the state that will get updated, on each block. And so I think at a very high level, like, this is just an important concept to understand before we get into the weeds of the Bancor Simulator state class. Just to understand like what we're doing, from a high level, and making sure that when you do go digging into our Bancor protocol research GitHub repo, and you drill down to a directory called spec. This spec, of course, refers once again to the BIP15 proposal, and the different Python files in here are all organized around different concepts with the simulator. And so today we're talking about the state.py file within this directory. And so if you navigate to the repo, you go to the spec directory and to state.py. That's what we're talking about today. And I just wanted to draw some high level imagery and also some examples of similar types of things being done around simulating the current Beacon Runner updates and so forth that are happening on the Ethereum network. So, Mark, I've been talking for a while. Do you have anything to add, or that I'm kind of glossing over too quickly here?
No, I think it's fine so far. I might have some stuff at the end to add, I guess, in terms of like heuristics. So I might share my screen and just do something on Excel or something to demonstrate how how we can think about states and how we pass these things around. But I was wondering, like, in this presentation, are you going to be discussing like how in the simulator we handle sort of the um, like the volatile state before we kind of like what are your plans for the rest of this presentation?
Yeah. So just kind of going through actually, if you're trying to change certain things or simulate certain things, one of the most important things, in my opinion, is just knowing where to look for kind of the code that you need to be focusing on, right? And so today I was thinking that basically just covering the main classes that are within state.py and kind of what they're doing. Um, so if you're looking to access some, the staking ledger or the vault balance, or modify some of the parameters, these are all going to be done within the state.py code. And so my plan was basically just to kind of cover that and where to look for these types of things. But of course we can jump into some other things if you think of them.
I think that's a completely reasonable way to approach it. I think that I can see we got a bunch of people on the call with us. It's I think it's super important that at least for this point in the series, there's going to be, I think, 9 of these presentations moving forward. It's pretty critical that you understand what the concept is of a state machine and what it means to have the state that's being modified. I just wanted to, if anyone wants to ask a question at this stage, or if you want, you can request that we look into, further elaborate on the idea of a state machine. Is everyone does anyone have any questions or concerns up till this point? Like, I don't want you to be shy. It's totally fine. You can insist that we explain it. I can, I offered before, that I can share my screen and go through some, quick animations or something. I can run a super crude state machine example in an Excel spreadsheet if that's helpful. But you have to tell me to do it. But if no one raises anything, I'm just going to assume that the idea of a state machine is perfectly clear, and that's not unreasonable. I think if you've been in blockchain for a little while, you've been programming for a little while. State machines are probably not a new idea, and so if there is no objections raised, then I think that we can just continue.
Cool. So I guess going along that direction, when you get to the state.py code, and you'll start out noticing we've got all these default values, which we can get more into, but you could overwrite these. For instance, if you want to just have the system start out at a specific state without even having to like reset everything, you could very well download the code and just overwrite these values, hard code them, and that would kind of get you going pretty quickly without too much effort. And so you could kind of run the default v3 behavior with new values just by overwriting these and running it. And we're going to cover how to run it exactly in a different session. But for today, the main points are that if you wanted to start out with different default values, you could come to this state.py and overwrite these default values. The token class that we're looking at here is used pretty extensively throughout, and this is typically going to be for like a balance, right? So it could be a balance in a user's wallet, it could be a balance in the vault, it could be a balance in the staking ledger. And supposing we want to add some amount to the existing balance, or subtract some amount from the existing balance, or overwrite or set a new balance, these are just methods which we can call within this class to perform those type of operations. We use a data class, which is a Python, a specific type of Python class, which is really meant to be a data container, very similar to what a state object is, or the state concept is doing. And so this is, data classes are used in a bunch of state machine code bases that I've come across. And so I think it's pretty intuitive that they make a lot of sense to use here as well. With the global settings, we're really just using this class to inherit certain attributes through other classes. So any class that we talk about that inherits the global settings are going to have all of these different attributes available to the class that's inheriting them. We, again, just by overriding the default values above, that would automatically update these global settings that are going to get passed down via inheritance. We've got some different classes that handle like the V3 cooldown and standard reward programs, right? All of the different attributes that we're using for tracking standard rewards, for tracking the cooldown states and auto compounding rewards. Hopefully the naming conventions are somewhat intuitive, and we're not going to have time to get into every single attribute of every single class, but I just want to cover like the main ones so that you can find your way to where you would need to in order to keep digging in on this. The users are going to be, they actually require a unique name. And they can have associated, pending withdrawals, pending standard rewards, and then their wallet, which is going to have tokens based on the token object or the token class that we discussed above. Any of these can be referenced. If you're not familiar with, this type hinting, what we're saying here is that the wallet is a dictionary. The dictionary has a string as a key, and like the key value pair, the value there is going to be a token object. And we do that really just to provide like your IDE or whatever sort of coding tools that you're using to understand what to expect in terms of like types of data that are being passed around. So for instance, if you have a function that expects an integer value, and it's passed like a dictionary, then your most coding tools will be able to forewarn you about that. And if you don't have that information, then it's really no help. But if you do have it, then you should be able to almost automatically fix and troubleshoot the code as needed. We have this an additional class called tokens, which it's very similar to, I wanted to call this class pools. However, there are a couple reasons why that's not technically correct. And so we went for the more general term tokens, where like every whitelisted token within the system, aside from BNT, should have a corresponding instance of this tokens class. And, so for instance, ETH is going to have all of these different attributes associated with it. And you can see here that we're passing in the global settings. So any of like the global timestamp and these other different values that were in the global settings are automatically going to be available within this tokens class. And additionally, we're kind of tracking all of these different state variables, right? And so when we talk about modifying the state or updating the state using a state transition function, the state transition function is going to take the current state inputs, which are literally all of these, right? So the master vault balance, the staking ledger balance, the pool token supply balance, any protocol wallet pool tokens, vortex ledger, so on and so forth. All of these are part of like the input state, and the state transition function is going to perform some sort of computation or operation without keeping in memory any of this information. It's just going to perform the operation and provide the output, right? And the output will be whatever the next state is after the operation is performed. So these values within the class will change, and we will get into it next time when we talk about more of like the programming interface that you'll use to interact with these classes, because in general you're not going to be interacting directly with any of these classes, but rather through a high level class that provides like almost an API for it, right? So I know that there's a lot of information to cover here, but within a Jupyter notebook, and this is going to assume that that you've kind of set up your Python environment and installed the Bancor research library, and you've got a Jupyter notebook up and running, right? So if you don't know how to do that, there's great tutorials all over the web about how to do that. But assuming that you've kind of gotten that far, you can just open up a Jupyter notebook and import the Bancor research simulator and the v3 spec, right? And from there we can just we can create an instance of the state class. And if we jump back over to here, just I think I passed it. State class is going to be the main class within the state.py file. Again, we're inheriting the global settings. So you can, just see, like you can see with these attributes that we have here, for instance, we can access any of the like BNT min liquidity, for instance, right, which is passed in through this inheritance. So you don't see BNT min liquidity in any of these state attributes here, but if we look up into the global settings, we should see it right here, right? And so that's once you've instantiated this class, then we can just access these variables that are in the global settings, or any of them that are specific to the state class itself. So with that, I know we're about 5 minutes until we're at the half-hour mark. So Mark, do you have anything to add here at this point? I'll give my voice a rest.
Yeah, no, sure, I'll give you voice a rest. So I just really sort of wanted to maybe provide some orientation here, I guess. So the purpose of today's presentation, this is all recorded. So if we want to go back over it in any time, this will all be uploaded to YouTube, and you can later after you've had some time to digest maybe some of the information that's being presented, and we're trying to do this in sort of small 30-minute bites rather than do like one gigantic 4.5-hour presentation. We're splitting this up into 9 smaller ones over a few weeks. I would just say that the purpose of what we've discussed today is really just that, the simulation, it is a state function. And maybe I can share my screen. Maybe I've got I said on the community call and previously that, I'm encouraging people to, who may not have any previous programming experience to join here. And so it's not clear, whether or not people are just shy or something. Can you guys see my screen, by the way? It's not clear to me. It should just look like a black grid or...
Yes.
Oh, great. Okay. So yeah, I guess just, I don't want to be too assuming, who in our audience is kind of familiar with these concepts. But I've got like I was kind of racking my brain for really interesting sort of demonstrations of state machines and state functions. And there are a couple of really cool examples, like, there's some iterative functions and things, and especially from chaos theory. But this is a completely non-related simulation based on something called Conway's Game of Life, and it is it is itself a state machine. And so essentially, what you do is you kind of color in these cells a certain way, and then when you progress to the next state in time, there are some rules here that determine how the lit cells are going to change, and how like the dark cells are going to change. And you can look up these rules later, but it doesn't really matter what they are. All that matters is that essentially there is a global setting, right? A list of instructions that say that if there's a cell that's dark, but it's surrounded by at least 3 lit cells, then in the next frame, that cell will be lit. And there are other rules that determine which lit cells are going to turn dark and so on. And those global settings, right, for this really basic, mathematical object, are exactly akin to those global settings that Mike was talking about when we were going through the global settings class, right? That there are these things, this list of variables, and there are other functions embedded in there that sort of determine how those variables will be used. But yeah, so in this one, you can sort of see as I let this thing run, every single time that you see something switch on or off and this thing kind of progresses, each one of these frames you can think of as a different state of the system. And so as we move from state to state, those rules are just being applied recursively over and over and over again to achieve a certain result. And those rules are being applied in an unchanging way. But of course, as you know, the settings on our protocol can change, and that would allow the next frame essentially in our simulation to be subject to a different set of rules. And so I think, if nothing else, what I want you to take away from this particular example, other than the fact that it's quite beautiful to watch these things evolve and things, is that the simulator that we have, or that Mike has put together for us in Python, it really is kind of a completely sort of text-based version of the protocol that evolves in time, the same way that this game of life simulation can evolve in time. And for anyone that's kind of been who's already wrestled with state machines previously, you might be sort of just rolling your eyes at the obviousness of it. But I think for many, it's a new concept. And in a way, a lot of the protocols on blockchains often can feel like calculators, right? Where you just kind of put in a certain input, and then it generates a certain output, and you've got your answer. Either that's some tokens that you're trading or something like that. And it's non-obvious, I think, to many, that there is this kind of block-to-block transition where where each block in the chain represents the entire state, right, of Ethereum at that time, and within that block there is a component that represents the state of the protocol, and so you need to read, right, all of these values, whether it be the swap fee or the available liquidity and so forth, and in a way that's kind of got a parallel here as being the which cells are lit up and which ones are still dark. And then when you call certain functions, such as a trade or a deposit liquidity or remove liquidity or distribute rewards or something like that, all of those outcomes need to be calculated, and then they get written to the next state. And so what you're looking at is kind of this series of snapshots, right? This series of photographs as the protocol evolves in time. And with this simulation that we've created in Python, you can actually go back and have a look at any of those states. So if there's, if you run a very complex, sequence of events where people trade certain amounts, and you've got, liquidity being added and withdrawn, and you're changing the swap fees and things like that. Each one of these frames of the simulation gets saved inside its own state. And those states can always be accessed. So you can roll back in time the same way that you can roll back in time on a blockchain, and see what that state was and kind of map how all of these transitions between states occur. And so I think, just as an overall sort of take-home message for this presentation, that the simulation is a state function, that there are a collection of settings that determine how each frame in the simulation changes as we progress forwards in time, and that those settings can be changed, is the most important takeaway. And then some of the things that Mike was going over there is just looking at which of the classes inside the simulation control those parameters. And so if you wanted to simulate how something would happen if you gave it a certain bias, or if you don't like a certain setting and you want to see how it affects the health of the protocol as it moves forwards in time, then those are the classes that you want to be paying attention to. And I think that's probably the all I wanted to say about it. But Mike or Jen, if you guys have anything else you wanted to add, go ahead. And otherwise, I think we should open it up to the floor for any questions. And if there are none, then I guess we can maybe, Mike, do you want to comment on what we can expect in the next presentation or something?
Yep. There's some questions in the simulator channel. You guys should take a look there and maybe just answer those.
Yeah.
Mark, while you're looking for those, I'm just gonna discuss like the next session is going to cover the Bancor DApp class, which is really the interface that you as a user of the simulator will be interacting with the most. And so when you create a new simulation, you're going to use a class called Bancor DApp, which is meant to imitate the actual Bancor DApp and the user interface for you to have a user who performs a trade by calling trade and specifying the tokens that are involved and the amounts that are involved to this class, which will allow you to really make use of the state classes that we talked about today, which on their own are classes which you're not likely to be interacting with a lot, unless, of course, you want to modify, uh, or customize some of the behavior of the state itself. But in general, the Bancor Adapt classes and what we talk about in the next session is going to make this much more hands-on, and we can actually run through, some really simple actions like a trade or a deposit, to kind of bring home the point of how we can change the state through this Bancor DAP class. And so with that, Mark, maybe you want to read out the questions that are in there.
Yeah. So Stella is asking, does a class work like defining a variable, just instead of one instruction, it is a set of instructions? This is kind of classes in Python and in C++. I was first introduced to them, as a programming object, thinking of them as like a form, right? It's like something that has a very specific structure. But Mike, maybe do you want to give us how would you explain what a class is to someone who's just sort of learning programming for the first time?
Sure. So if you're familiar with the concept of a function, so we talked today about these things called state transition functions, and a function is really just some logic that you want to perform on an input. And so if you think a class, in my mind, there's a couple nuances with like a object-oriented programming language like Python. But the class, I think of it generally as a related collection of functions. So if we look at the state class, for example, right? What is involved with like updating the state, right? And we can have all sorts of different things, but some of them might be like we want to increase the external rewards vault balance, right? We want to decrease the external rewards vault balance, or increase the pool token balance. So all of these methods are really just they're functions that are related in like a pretty integral way to the state class, and are going to be performing some operation on the attributes. So by the time we get to the state class, right, we're actually using other classes, which are things like the users and tokens and the auto compounding reward programs. So when we perform an operation on the state, we can access any one of these other classes as an attribute, right? And the functions or methods that are a part of this class are going to make some sort of changes to the state. Now, I guess I'd leave it at that. So the best way to think about a class in Python is it should be at minimum like any number of functions which on their own are related in an intuitive way, ideally. And then so I guess I'll stop there before I talk forever.
Stella also asks, are there parts of the protocol that will start to evolve eventually? Of course. One of the reasons that we created the simulator and why Mike has gone to so much effort to make sure that it's well documented and installs via pip installer and everything, is because we want this to be a community resource, and it can be used to demonstrate certain concepts that people might want developed, right? Or even assist them in developing them themselves so that they can be implemented on chain. And so, I think that the reason why we've kind of switched gears a little bit from, just taking proposals off of governance and showing how those can be simulated, which I think set a bad precedent in terms of why the simulator exists, because it's not it's not necessarily for for Mike and I to go through governance all the time and try to program the simulator to do these sorts of things, but more I think to as like a learning resource, but also as a tool for people to explore ideas before some of these things end up on governance. And so with that in mind, absolutely there are going to be ways that that I am already using the simulator to test how things work and simulate how something might how the state of the protocol evolves in time by changing certain parameters or introducing new features or different logic and so on. And so these inform our decisions in a much more a much more objective way, I think, is the way that I can the way that the best way I can attach value to what we're doing here. So as these concepts develop and gain traction, then they will be added to the simulator. And certainly, a lot of the stuff that I spoke about on the community call just yesterday, we'll have a simulation module for that as well, right? And everything that that the protocol does into the future will have this kind of support, so that the community members can use it and learn how it works and that kind of thing, without having referred to specifically the smart contracts. And I think, as I said previously, this is also going to be used as a type of testing suite that allows the smart contracts to receive an entirely third-party source of verification for their tests. I think that's I hope that answers your question, but if it hasn't, go ahead and you can ask another one in the chat, and I'll stay on Discord for a while longer. So if there are any questions at all after this presentation, we can pull it up with that. But otherwise, I think we're at almost 45 minutes. Oh, we've got how does the Bancor state class relate to the state tab of Etherscan?
Could you repeat that one more time, Mark?
Yeah, so Silent is asking, how does the Bancor state class relate to the state tab of Etherscan?
So, to be perfectly clear, this is going to be entirely independent of anything that's happening on chain, right? So, it's meant to imitate what the Bancor v3 on-chain contracts are doing in terms of processing a transaction with a given set of inputs and producing what can be expected as the same outputs as would be the case of an operation happening on chain, with the main difference being the speed that transaction can happen, and especially when you're doing hundreds and thousands of these sorts of actions, you can obviously process them much faster with a simulator tool like this than you could on chain. But yeah, just to reiterate, so there is no direct link with anything that's happening on chain.
It's a conceptual one, though. I think. Wait, I can't remember are we using block numbers or timestamps at the moment for?
Timestamps is.
Timestamps, yeah, fine. Okay, but so yeah, there were several versions of what we wanted to name each state, essentially, right? So those frames, if you like, as the simulation progresses. And obviously, the one that is the most intuitive when you're in a blockchain environment is just the block number. And so, for any simulation, you would just start at block number 0 and let the block numbers tick up over time. And then we eventually sort of settled on using timestamps instead. But you can use these, these are just names. You can use these terms interchangeably. But, there are direct conceptual parallels, even if the link between them in the real sense is tenuous.
Is that all the questions?
I think that's all the questions.
All right. Well, I guess with that, I'm going to stop the recording, and we will put that up on YouTube and share the link. And I can also share the short PowerPoint and some of the links that I had open during the presentation for anybody who might want to, check them out and walk through this again on their own time. But thank everybody for joining, and we will see you on Wednesday, I believe.
See you on Wednesday.
Cool.
Thank you, everyone.